Hello and welcome to my new video. This is the 12th video now, and in my previous two videos I explained what is hysteresis and what is hysteresis loss in magnetic circuits. So I hope I did a good job. If you didn't watch my previous two videos, or I would advise you to watch all my videos in these lectures. You can see the link on my playlist in the description video. Now there is I explained what that hysteresis loss was. One core loss in the magnetic circuit. Now there is another loss in magnetic circuits, and which is less important than hysteresis, but also important, and that loss is called the eddy current loss. So now when we in alternating currents and in magnetic circuits, we have a changing magnetic flux density, we have a changing magnetic field. So we have a B, magnetic flux density, that goes in some magnetic circuit, and it is changing. And if it is changing, then there is going to be induced current in those magnetic circuits. Why? Because every material, especially magnetic material, has electrons in itself. So when a current is changing, those electrons are going to spin around in these magnetic materials. So when electron spins around, it has its own closed loop. Electron has its own charge. It is small, but electrons are very fast, and they're very fast rotating. So you have some induced currents in the magnetic material, and those currents are called eddy currents. So I in index E, and this because the core itself has its own resistance, there is a power loss that is equal to, that there is a heat that is equal to I squared times the resistance, so Joule's law. So we have to find a way how to avoid this current loss. How can we make these core losses smaller? There are two ways. So one way is to make this core more resistive, because when we have a more resistive core, small induced voltage, small current, and the smaller the power loss. And how do you make higher? Well, to make higher resistive magnetic cores, you have to make a ferromagnetic material which is going to have a 4% of silicon. Oh, sorry. So you have to forge the magnetic core with this silicon sheet metal that has 4%. So you have 4% of silicon sheet metal of the magnetic core. Higher the resistance of the magnetic core, the smaller the current, and this will be smaller. Because I squared is that, when it's squared, is that who makes the loss. Not resistance is smaller. You see, I squared, and the resistance is smaller. So yeah, that's the first way. Now, the second way is to make laminated magnetic materials. How do we do that? For example, here you have non-laminated magnetic material, and here you have laminated magnetic material. How do you do that? So you cut this magnetic material, you cut it for example, from here to here, and the thickness of this lamination is usually from 0.5 to 5 millimeters in electric machines, and in electronic circuits, if you have magnetic circuits, you need from 0.01 to 5 millimeters, because I'll say why. So we cut these magnetic materials, we put an isolating material between all these materials, and then these eddy currents all here are going to be much smaller than here when there is no lamination, when it's only one magnetic material. So here you will have smaller eddy currents. Smaller eddy currents, smaller power losses, smaller heating, and that's how you reduce eddy current losses. So you make these magnetic laminations smaller, cut them smaller, thinner and thinner. You put an isolating material that is much more thinner than this laminating magnetic material, and then there will be smaller smaller amount of electrons that will circle, so smaller currents, and all of electric machines, usually all electric machines are laminated and stacked together, and there is an isolating material that we must reduce these eddy currents to make them smaller and smaller the power loss. And here we have a formula for the power eddy current loss. So power E, here eddy, is equal to, this is a constant here, and it depends on the thickness of this laminating material and the type of magnetic material. So you can calculate it, it's experimentally done, times the magnetic flux density squared times frequency squared. So as you can see, in hysteresis loops we had frequency that is not on squared, that was just frequency, but here we have here that the power eddy current loss, the power loss here, is going to be directly proportional to the square of the frequency. That's why in electronic circuits, if you have a small transformer for stepping up and stepping down the voltage, if you have a transformer, you have to make this laminating material thinner than in huge electric machines, because in small electronic circuits frequencies are much higher. For example, megahertz, gigahertz, kilohertz. But in electric machinery we have usually frequencies about 50 to 60 hertz. So that's why in electric machinery this laminating material is thicker than in electronic circuits. So this is the formula for the eddy current loss. So hysteresis loss and eddy current loss are the two losses in magnetic circuits, and that's why you need to know what's going on for the mechanical design of the electric machines. So thank you for watching, and in my next video we're gonna do the core loss, so this and hysteresis loss together. So see you in my next video.